All right, so this is the color theory day. So first we're going to talk a little bit, I've already used this word before, but chiaroscuro is the light and dark. It's the conflict between light and dark, contrast. So it's the use of light and dark in painting or sculpture for the purpose of creating an enhanced three-dimensional effect. So as you can see on the ball here, we have lots of highlights, the most brightest part. We know this stuff from if you ever do any three-dimensional painting. The most important two things you need in order to do some kind of painting, some trompe-l'oeil to fool the eye, is a highlight and a shadow. That's like where you start. But there needs to be a gradation of that, right? So light, shadow, reflected light, which gives that ball dimensionality. So if we're looking at Martin Luther here, and we go ahead and bring up the intensity, now he's a little translucent, but you can see you've got the darkness in the folds. A lot of Renaissance painting that uses a lot of chiaroscuro has light from one point. And so that's often why I always say one of my favorite lighting instruments is actually the 10-inch Fresnel, because you can have a really, like a 2,000 watt 10-inch Fresnel, right? You can have a lot of intensity from just one source, and then you get a lot of really intense shadows that are not interfered with by anything else. It might just be one show I did that I was really proud of, but I still really like them. And especially this is affected by where Martin Luther is. You know, if we are really focused on him, where the light is focused on his chest, which is where I try to focus most of these lights here, you know, he looks different based on where within that light beam he is. And this is, of course, these are little mini pars, if you're curious. So these are par 16s and a par 20. So the par 64 was the big guy that was on your test, right? And these are small. We also call these birdies, because they're one less than par, or two more than par is the 20, right? Oh. Yeah, and the 16s are two less than par. So usually these little ones are the birdies, we call it. But, so it's a golf joke. Spoilers. So chiaroscuro, here's another example, as I was talking about, really sort of one source of light. Where would you say the source of light is coming from on this image? Anyone? Yeah, top, yeah. So it's hitting his arm here, clearly, and then shining down this way. Right. So the arrangement of light and dark parts in the work of art, such as drawing or painting, whether in monochrome or in color, the art or practice of so arranging light and dark parts to produce the harmonious effect. So that's what we do as lighting designers, right? Yes?
Is it usually single source?
In Renaissance painting, it's largely single source, so you'll often see just like a candle, and that's what's lighting the table around it. Now, we as lighting designers very rarely do just single source for a prolonged period of time. We're almost always sneaking in other angles of light because, of course, seeing the face is very important. And you can only really get away with a lot of single source in a space like this one. You could probably get away with quite a bit of single source lighting in this room. Does anyone remember the word that we use for that in the objectives of lighting design? Anyone?
Visual acuity.
Visual acuity. And specifically, what part of that one?
Can you repeat the first part? Because I might know the answer.
Sure. So there's different parts to visual acuity.
Yeah.
There's like 4 different parts. Why would it make it easier to see lighting in this space, or have lower lighting in this space, as opposed to over in the main stage?
Because you're closer.
Because we're closer, right? And that's visual scale, right? So when you're closer to a person, they appear larger to you, so you can use less light. Whereas if the person is farther away from you, you have to use more light in order to be able to see them better. Make sense? Okay, great. A little review. So here's some color terminology: hue, saturation, value, and Tint. So we're gonna go through what these are, and they should be on your little list. Oh, look, they are. Great. I love guides. I loved 3 years ago me. Okay. So hue is a specific wavelength of the visible light spectrum. These guys.
Whoa.
And this somewhat exists because as we go through this lecture, I'm going to use this color board so you can see how different colors of light affect different pigment colors. This is the visible spectrum of light. And so if you're looking at cosmic rays, gamma rays, X-rays, ultraviolet, infrared, microwaves, radar, radio, broadcast band, right? All those are not visible, right? Those are all the same science. But the visible light spectrum, right, has to do with everything from that begins after ultraviolet and is before infrared. Can anyone think of in theater what we use infrared for?
Sorry.
We'll raise hands and so raise hands.
I bowed out.
You go. You bow out. Okay.
I bowed out.
What do we use infrared for?
Well, I raised my hand, but I guess like remotes.
I thought you did. Okay, sorry. Remotes, yeah, sure. We're using remotes, so that could certainly be something. There's something else yeah.
But could you use, isn't it ultraviolet for it's not called fluorescent, but it's basically, you also see this in movies and whatnot, whenever they do something, then they use the special light to see stuff that you wouldn't be able to see with a normal.
Right, that is, you're talking about ultraviolet.
Yeah.
So hold on to that thought. We're gonna talk about infrared first. But you're right, you're on the right track. Infrared, has anyone ever used a camera for dark light?
Yeah, I was thinking of an infrared camera for when people are set in a blackout to know, so you can see where bodies are on the stage in a blackout.
Right, so stage managers often, I don't know, do we have one still or did we
have a baby
one?
monitor.
Yeah, we have the baby monitor here. But a lot of theaters will have an actual infrared light pointed at the stage with a camera, right? So that you can see. Essentially, it looks kind of like green or gray depending on the quality of the infrared camera. So the stage manager can see when someone has put something down left, right, and you know when to start the scene, or when the actors are set. Because it can be really difficult, especially in a space like the main stage, right, where to know that. And you can, of course, do that the analog way, which is to just tell someone over headset that they're ready. But it can be just a little faster for all those transitions if you can physically save yourself. And then what you were talking about with fluorescent for ultraviolet, did you want to say more about that?
The infrared, basically night vision, night vision goggles.
Right, yes, absolutely. So ultraviolet has to do with what you were talking about. You're right. If you have fluorescent or ultra or UV reflective paint, it's mostly invisible. So it kind of looks milky. If you would paint a just clear ultraviolet paint on a stage, it would just, on black, it would just look milky. But then when you turned on the UV light, it would look sort of like a bright yellowish or a bright greenish, right? So I've seen lots of cool techniques used in that way, but you do have to have a pitch black space and true ultraviolet lights for them to work correctly. Can anyone else think of anything else that ultraviolet is used for in theater?
When I saw Six, they had a particular song, and they all came out in these white collars, Renaissance style, and they turned on a black light.
Mm-hmm. And then it made the white look extra vibrant,
Yeah.
right? Yeah, absolutely. So I worked for a blacklight dance company for several years. I sold them. That was the first time they were integrating intelligent lights with their UV lighting. But traditionally what they do is they literally would use cardboard or fabric or all kinds of things and paint these really intricately beautiful fluorescent and UV paints on them. And in pitch black, if you're wearing black, you are invisible if you have the right kind of UV light and the right kind of throw. If it's too bright, you can actually see black. So that's one of the problems they had with one of their UV lighting instruments. And this is important for you to understand as lighting designers because you may need to do an effect like this, right? But they would do really cool stuff. So a dancer would stop and they would do this. And they would had lots, they were good dancers too on top of all this. And they would be able to hold their pose while someone lifted them up. So it looked like they were floating, right? So they did all kinds of cool effects with that. And they eventually integrated traditional lighting into that, but then the traditional lighting intelligent lighting would need to be shut off whenever they were going to do effects like that. So it's sort of a cool mixture of the two. Anyway, so everything between those two things is infrared. You can't get away with doing some ultraviolet effects if you use some of the visible spectrum that's right here in this violet range. You can sort of make fluorescence appear more fluorescent. So that's why I have sort of a fluorescent pink up here. It's not a great fluorescent pink, but it's still a fluorescent pink. That if you do turn on like a true violet gel, you can make fluorescence read more fluorescent if you use that. So this is what you see. When you look at a gel book, and I was going to have a gel book for everyone because I have a stock of them, but I currently only have some gel books. I'm going to toss them at people, so get ready. All right, Lily, you're first.
Yes.
Okay, not throwing me. Okay, yes, Tori.
I got it.
What is it?
All right,
Roscoe?
they're all Roscoe.
What? Yeah, look at it.
All right, I've got some non-Roscoe. I'm going to toss these at you two. Who wants a lead?
Lee.
Who wants a GAM? Wait, you two in the back don't have one. You're going to get GAM. Oh, that was hooked. All right, so I've got more gel books for now. Just borrow someone that's near you, hopefully. Sorry. So I'll give you a second to look at those. Some of you have looked at them before. Some of you have not.
That's so
Yeah, Wes, just go ahead and take a look at those.
That's so
So on these gel books, you see a little graph for what the actual visible spectrum is, or for what that particular gel is, wavelength is, okay? The actual real term for gels is color filter. Because what you're doing is you're filtering out part of the wavelength to get that hue. Does that make sense? So what you're looking at on those gel books is something like this. And people often think that if you're looking at the book that it goes from red to violet because we're used to Roy G. Biv, right? But it's actually the opposite direction. It's violet on this side and red on this side. Okay, so every gel color in GAM or Roscoe's database, you can go online and you can get a color filter technical data sheet like this. And this gets into the science of lighting called chromasticity, but that's grad level stuff, so I'm not really going to do that right now. But we had to, in grad school, chart stuff to like find out what two colors would mix to what color and then test it out, that kind of stuff, see if we were right. So that's what this chart is. This is essentially the wavelength. You also might notice this from the color picker if you're doing LED stuff. So I'm not going to get too deep into this, but it's important for you to be aware of at this point, and we'll circle back around to it. Yeah?
This one is not being important, but is there much of a difference in like the color picker when it's round versus like this shape?
So this is more true to where it actually sits on the wavelength graph.
Right.
The round, I think, is just more accessible for some people to understand. I don't think it's all that different. The color picker also is a lie, so I mean, it's nice. It gets you close to the color you actually want, but it's really kind of not, right? That technology, I'm sure, will progress because it already has. I mean, 15 years ago, I was sitting in what our version of PNTA was. Oh, it must have over 15 years ago. I was sitting with what our version of PNTA was, and they were talking about how it would take 10 years for LED technology to finally be what it is today, and they were right, it did take 10 years. Anyway, I'm digressing. So saturation or chroma is the next, I tend to use the word saturation, but you may also hear the word chroma. Refers to the amount of a particular hue in a color mixture. So high saturation is intense color, and low saturation is generally pretty pale. So it's a majority white light, and I will always use quotations when I say the word white or gray. I'll let you finish writing. So a very saturated color, right, is something like that, right? Spooky Martin Luther. It is Halloween, right? I'd say that's a middle saturation, maybe. This one's very saturated,
It's Martin.
right?
Cool, we got this.
But if you mix in more white with it, with additive mixing, which I'll get to soon, right? That makes it
That's
less
so
saturated,
cool.
right? But yeah.
Oh my gosh.
It also shows.
Man, Tori, you're gonna love this lecture.
It also shows like the effective angle of light. 'Cause
Correct.
there's a whole bunch of red sitting on the side of them.
Right, you're getting that in these folds,
That's
right?
why it looks cool.
Yeah, we're gonna see a lot of that. It's gonna be fun. You just wait. Today is more lecture, and next time is more like turning on lots of cool lights, but this one involves turning on lots of cool lights too. All right, great. I'm gonna take this down. Oh, you have no idea how much having an iPad has changed how awesome this color lecture is gonna be to do. The next term is value. Sorry, yeah, did I skip over tint?
No, I think it's after value.
Yeah, you're right. Sorry, different order. Value, the relative lightness of a color is referred to the value. So a high value is a lighter color, and a low value is a darker color. This is hard for people to wrap their minds around because the high value term is just not, it just doesn't work with a lot of people's brains. It just takes some practice. So here's a visual representation of high value versus low value. So a high value color is yellow, if you're just going to look at it straight by a hue difference. So in a hue difference, yellow is a very high value color, whereas violet is a very low value color. And so what the middle one does is it gives you a sense of that by just simply converting it to a gray tone, right? And then you can also look at this version, right? So you can see that low value versus high value in a grayscale version, right? And this is what allows people who are colorblind to still tell the difference between colors, even though they may not see red and green as different colors, they usually have a different value. So for instance, are you colorblind?
Yes.
All right, cool. I've had lots of great colorblind lighting designers. Like you really can still do everything anyone else can do. But that's something that I wanted to try to be conscious of when Isaac and I were labeling the links of cables. So Isaac brought up a really cool app because Isaac's partner is colorblind, and so he already had that. And so the app is like it's like all the different major kinds of color blindness. And so we tried to hold that up to the tape we were using to pick the ones that had the largest value difference. Does that make sense? Yeah.
So can you say it again? High value is?
High value is a lighter color. I'll go back to the previous slide.
Thank you.
High value is a lighter color, and low value is a darker color. Think of it as high light and low light.
Oh, yeah.
With high value, high. And yeah, this gets confusing with high saturation because high saturation is a more intense color. So you would, that doesn't work. Highlight doesn't work for this one, but highlight does work for value. This is like art terminology. This is the same stuff you'd be learning if you were taking an art class.
I'm in an art class.
Yeah, hopefully it overlaps. And so then tint is what I was doing earlier with bringing up some of the red, right? And some of this. I mean, yes, there are different angles. So you're still getting this red in the folds. But the, but mixed by adding some white to that, I'm creating a tint of the red instead of just the pure red, right? So a tint, though, can also refer to a kind of gel. So the gel, a gel that has a very low chroma or low saturation is often referred to as a tint. So if we have this bit of RO2, we'll put this in this little light right here. There you go, buddy. Oh, small. So this, you can barely tell that it is gelled right now. It's RO2. It would be more intense if it were in a different kind of light right now. But this is a tint of amber because it's letting through a lot more of the wavelength, the other wavelengths, than just the amber wavelengths. Does that make sense? Questions about that so far? Okay, good. I mean, not good that you don't have questions. Great. So tone in lighting. We can't mix white and black like you can in pigment, but we will layer a toning light over bright and dark spots of the stage. So this is what I was talking about with downlight. So a downlight is a toning light. So toning lights are often, so this is why in this space, I almost always put the desires as downlight with some kind of Parnell or Source 4 par that we can put in pretty intense colors. Because what that allows is when the light is hitting you from whatever direction, maybe you only have a single source of visibility, and then there's a shadow falling on the ground. If you then have a downlight, it tones that shadow to be whatever color that downlight is. So you could have a blue toning on the ground, right, of the light. So that's just to be aware. So it makes the shadows have that color and additively contributes to the bright spot. So also that toning light will turn, let's say you just have a pretty neutral front light, the downlight, the blue downlight will make that that front visibility look cool. Does that make sense? So what we've been talking about so far is additive color mixing. So additive color mixing is when you have various colors that you're mixing together. So I'm going to go back one before I talk about this because I realize this is a practical example. So here I have blue, I have green, and I have red. These are the primary colors of light. I just really want to check right now because it doesn't seem like this is actually R91. I guess it is R91. I'm just going to put this in here too. There we go. Okay. So these are the primary colors of light: red, green, blue. Don't forget it. It's very, 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 very important. So these are the primary colors of light, are red, green, and blue. If you have all three of them on, theoretically, and this is big time, theoretically, so red, the thing to remember is red always beats the crap out of the other colors. So if you're trying to mix to white using red, green, and blue, you have to adjust the other ones. And green usually tends to, and so, let me just mess with this a little bit. So what we're always doing is mixing to white, theoretically. The only way that you can truly mix to white is using lots and lots of science and perfectly calibrated lighting instruments with perfectly calibrated colors. There's museum exhibits that are awesome. Like I know friends of mine who have gone to a museum and exhibit in New York where they demonstrate the mixing of the 3 primary colors to get to white. And they have them slightly off because they're right next to each other. So you can stand in the way and look at your shadow. And there is a, you can see the different lines, the different colors of light combining to give you help. To give you, is this still okay?
Yeah, it's good.
Okay, good. To still give you that white light. So just like in pigment, has anyone ever mixed together the primary colors of pigment, yellow, red, and blue? What happens?
You get brown.
You get poop brown. So just like that, theoretically you're mixing to black, theoretically, but you're probably actually not. So just like that is true in lighting, but we've got these 3 very saturated colors, and because they're combining additively, doing additive mixing on Martin Luther, and they're all slightly separately apart, so you're seeing different parts of them in here. Even though they're all slightly separated, we're still getting a version of white. It's a very pinky white. But it's still a version of white, and I could probably bring this down and we can get different versions of white. It's still certainly less saturated than the sum of its parts, right? So these are the primary